Now I am going to take the case of a pure inductive coil. So, to case of pure inductive coil of characteristic L0. Now, a coil, as we said previously, the coil is characterized by L and R. When its resistance is 0 or negligible, I mean approximately 0 or negligible, then the coil is characterized by L only, and it is said to be a pure inductive coil. Okay? In the same way, I want to study the voltage of the pure inductive coil UL and compare it with the current I to see whether it leads or lags or in phase with I. I am going to do the same procedures as we did for the resistor. And also I am going to explain the experimental study and the theoretical study as well. What I am going to do here in the experimental study first, I am going to remove the resistor, the small r, and replace it by a pure inductive coil L. This is the pure inductive coil L. Now the voltage UAM, I am going to call it UL. Same procedures for the experimental study of UL are followed as those for UR, for the resistor. Channel also here, this is the ground of the oscilloscope that separate the voltages from each other. And channel 1, the phase of channel 1 is placed at A, and the phase of channel 2 is placed at B, so that the channel 1 reads voltage UAM and the channel 2 reads voltage UBM. And as you see, these voltages have opposite direction. So what should I do? I press the invert button that reverses the voltage of the second channel so that UMB and UAM have the same direction. Now, what do we observe on the screen of the oscilloscope? Similar to that, we observe the two voltages, UAM, which will have the following shape. And this is UAM, which I am going to call it UL. And you have the voltage UR. You will see that UR will have the following form. Okay? Okay, this is UR, which is the same as UMB. Let's see, also here, I can find experimentally the maximum voltage, UL maximum, that I want. My objective is to find it, which is equal S1V times Y1. Also, we can find UR maximum بتساوي S2V times Y2, from which we can find the maximum value of the current that flows through the oscilloscope by using the proportionality between UR and I maximum. Now, if you look at the two voltages, you will see that there is a phase difference between them. We said previously that the phase difference between the two voltages is this distance, this is absolute value of phi, or this one. So it is between two consecutive maximums, or two consecutive zeros, or two consecutive minimums, or two consecutive zeros when the voltages are increasing. Here, or when the voltages are decreasing like this. This is also can be considered phi. Okay. If you look at the two phases, at the two waveform, you can deduce which one leads the other. I want to ask you, which waveform leads the other? You will tell me that the blue waveform, which represents UL, leads the voltage I. Leads voltage UR, which represents also I, as we said, because it's proportional to I. So we deduce here experimentally that UL leads I by phi. But how much is phi? Phi can be calculated experimentally here in divisions. I can change it to phi correspond to 2D divisions. I can change it to radian by using the following formula, pi d over capital D, where capital D is the division of the period t, and I explained this and I prove it in the class. Now, if you apply this formula for this situation, we will deduce that phi is equal pi over 2 radian. Then we deduce that UL leads I by pi over 2. Since phi equal plus pi over 2, this implies, so, and also this should be memorized by heart. In case of pure inductive coil, UL leads I by pi over 2. This was the experimental study. I want to get the same results using the theoretical study. Theoretical study also similar to that of the resistor, the same steps here. I'm going to use them. Part B, theoretical study. Okay. Also here, I want my objective is to find UL maximum and phi of UL relative to I. Don't forget the objectives. To do this theoretically, I need to choose a reference. And always, during my explanation for this section, I am going to use I as reference. Since I is a reference, then it can be written in the form I am sine omega t. Expect the expression of UL. You should know the expression of UL. What will be the expression of UL? Of course, you should know from our first explanation, if I had this form, then UL, or voltage across the pure inductive coil, UL will have similar form. Yani this implies UL is equal UL maximum sine omega t plus phi. And as I said up, that I want to find UL maximum and phi. How to do this theoretically? Whenever we are talking theoretically, this means that I need a formula to start with. And as you know, Euler coil is equal when a current I flows through a coil, the phenomenon of self-induction takes place within the coil, and so the voltage across the coil will be Ri plus L di over dt. But since the resistance of the coil is negligible, I can neglect it, and I am going to use the formula like this: UL is equal L di over dt. So to find UL, I need the derivative of I with respect to t. So substitute, making the derivative, and substitute in the formula, you get L. What is the derivative of I? Im is constant multiplied with the sine, so I put it beside. Derivative of sine omega t is cosine omega t times the derivative of the angle, which is omega. So we get here L omega Im cosine omega t. This is the expression of UL. As you see here, what is the maximum value of UL? This is the maximum value of UL, L omega Im. Why? Can you say why? Yes, because UL increases as cosine omega t increases. So UL will be maximum when cosine omega t is maximum equal to 1. Substitute 1 and you will get UL maximum L omega Im. To find UL maximum and at the same time to find phi, look here, you expect, look at the given. The given current is in the sine form. Since the current I is in the sine form, we expected UL also to be in the sine form with addition of phi. We get here UL of cosine form. So to find phi, I should change it to sine form in order to compare between UL and I, so that I can find the phase difference. So using the trigonometric relation, cosine alpha equals sine alpha plus pi over 2, where alpha equal omega t, you will get omega t plus pi over 2. So UL will be equal L omega Im sine omega t plus pi over 2. which is in the expected form, in the form of UL is equal UL maximum sine omega t plus phi. So by comparison, you deduce that UL maximum is equal L omega Im and phi equal plus pi over 2. I is reference since phi is 0, and plus phi, well, phi is positive, so we deduce that UL leads I by pi over 2. Yani this implies UL leads I by pi over 2, which is the same result as the experimental one that we obtained. Also, if you have L and omega and Im and you replace here, you will get the same result, the same experimental result of UL maximum. Okay, this was about the pure inductive coil. Now I am going to take a third load, which is the capacitor. Okay, we studied previously capacitor when it is connected in series with a resistor and we apply a square voltage or DC voltage to it. Now here we are going to study the case of a capacitor in series with the resistor. So the same procedures are going to be applied experimentally and theoretically. What I am going to do is I am going to replace L by a capacitor of capacitance C, and then we proceed as we did for the coil, pure inductive coil, and for the resistor. So, third case, I am going to talk about a case of a capacitor. Also here I am going to study, to make experimental study, and as I said, what I am going to do is to remove the pure inductive coil and replace the capacitor of capacitance C. As previously, now channel 1 will read UAM, which is equal to UC, and the channel 2 reads UMB after pressing the invert button, which reads UR, in order to UR that have the same direction as UAM after I press the invert button, so that they have same direction. Now, experimentally, instead of redrawing the graphs together, I'm going to change their names, because this is what you are going to obtain, changing the names. So you will obtain a graph UC. This will be UAM, which is UC. Sorry, I am going to change them. So this one will be UBM, which is equal UR, and the black one will be UC, which is equal to UAM, and now UR represents I. يعني if I do this experimentally, if I do this in the lab, you are going to obtain similar graphs here, similar waveforms. And as you see, you will see you are first, then you see. So I changed the names of the waveform in order not to redraw them again, because they will be similar to this wave. Also here, I can find UC maximum and the current IM. Using these waveforms, you can find on channel Y2, Y2 or Y1, you can find UC maximum is equal S1V times Y1. Okay? On a channel Y1, you find UC maximum equal S1V times Y1. On a channel 2, you can find UR maximum, which is equal S2V times Y2, from which you find UR maximum over R. Now, if you look at the waveform, and so look at the waveform so that you tell me which one leads the other. If you look at the waveform, you notice that UR reaches maximum at time t1 before UC reach maximum at time t2. So we say that I leads UC. We say that I leads UC. Also here, same phase, pi over 2. If I do the same calculation here, I will get the phase difference also pi over 2. But instead, UC lags I by pi over 2. يعني this implies phi equal minus pi over 2. And also this expression should be memorized by heart. Every phase difference between you and I should be memorized. Now we have the theoretical study. The theoretical study in the same way. Now I want to find UC maximum and phi of UC relative to I. To do this, this is the expression of I. I am going to change UL to UC. This is UC. If I equal IM sine omega t, then you deduce directly that UC equal UCM sine omega t plus phi. And since I am working theoretically, I need a formula to start. What is the formula? The formula is UC equal Q over C. So in order to find UC, I should find the Q. And as you know, the relation for variable current is I equal dq over dt. يعني this implies Q equal integral I dt, which gives me integral Im sine omega t dt, which gives Im integral sine omega t dt, which gives Im integral minus 1 over omega cosine omega t plus constant. Okay? So you get minus Im over omega cosine omega t plus c, which is constant, c constant. So substitute Substitute for UC, you get minus 1 over omega C Im cosine omega t plus C, constant prime. Choose C prime equal to 0. So you get UC will be equal minus Im over omega C cosine omega t. Now to find UC maximum and phi at the same time, I am going to change this UC to this form. To do this, you should use the following trigonometric relation, tsewi sine omega t minus pi over 2. Yani this implies UC is equal Im ala omega C sine omega t minus pi over 2. By comparison, which is in the form UC equal UC maximum sine omega t plus phi, compare, you get UC maximum is equal Im over omega C and phi equal minus pi over 2, which means that UC lags I by pi over 2, and the experimental results is proved theoretically. And also here, if you calculate UC maximum Im ala omega C, it will be equal to UC maximum, which is calculated experimentally.